Welcome back, my calculus friends. Okay, we're going to jump right in with a fundamental theorem of calculus, which says that if we take the integral from a lower bound to an upper bound, right, from a to b, of some function, right, and most often this is going to be a derivative function, right, with respect to x, that is f of b. So notice now, right, this was derivative. This is the antiderivative evaluated at b minus the antiderivative evaluated at a. Okay, so that is what our fundamental theorem of calculus says. Right, so this is some function, and these guys are the antiderivative. So if this is our function, then we're taking the integral of a derivative. Okay, so let's see, how do we do that in practice for these types of problems? So let's see, given here we have dy dx, right? This is a derivative, f prime, with the initial condition y of 2, right? So that's the function when x is 2, y is negative 1. And we want to find what is the y value when x is 3. Okay, we're going to do it using the fundamental theorem of calculus. So 2, this is going to be your lower bound for our integral. And then this one, 3, is going to be our upper bound. Whichever number is smaller is always the lower bound. Or we can switch it, but let's just do that for right now. So we're going to figure out, we want the integral from 2 to 3, right? Because our first x value is 2 and our second x value is 3. Of our function, which is 3x squared plus 4x minus 5 dx. Okay, that's what we're doing, and we want to find y of 3. Okay, so doing it the antiderivative way, let's figure out what the antiderivative of this equation is going to be. Okay, so let's do that from 2 to 3. Okay, so what's the let's talk about how we do this. Remember, when we do an antiderivative, we always add 1 to the power, right? So it was 3x squared, it's now 3x cubed, and I multiply it by the reciprocal of my new power. So because this was a third power, I multiply by 1/3. Okay, plus 4x to the second power times 1/2 minus 5x to the first power times 1/1, which is of course redonkulous, so we don't do that part. Plus c, right? So we have this initial condition that we're going to use in order to figure out what our c value is. So we're finding our function, right? Our y sub x function, in order so that we can plug 3 in and figure out what the answer is. Okay, so let's simplify this down, right? 3 and 1/3 are gone. That's just x cubed. Half of 4 is 2, so that's 2x squared minus 5x plus c. Okay, so that's going to be our antiderivative. We're going to use our initial condition. When we plug in a value of 2, I get -1. -1 is my answer whenever I replace x with 2. So I'm going to figure out what my equation is so that I can then plug in 3 into that equation. So that gives me the equation x cubed plus 2x squared minus 5x minus 7. Okay, so that's my equation that I start with for when I take the derivative, I get this guy as my derivative. So now I can plug in positive 3 into my equation, right, to figure out what y of 3 is. So let's do that. Okay, and we get 23. So when x is 3, our y value is going to be 23. Okay, so that was doing it the antiderivative way, which is a perfectly good way to do it. and then using our initial condition to find our equation, right? This is our equation, and then plugging in 3 to get our answer. So now, let's use the fundamental theorem way, which you're probably going to like more, of course, because that's how we do it in math. Okay? So once again, the A value is going to be 2, and our B value is going to be 3. So let's set this up. Okay, there we go. Now, we're going to use our calculator to help us evaluate this. Okay? Because we know what f of 2 is. They told us up here that f of 2 is -1. Okay, so I can come down here and replace f of 2 with -1 automatically, right? I don't know what f of 3 is, and I'm going to use my calculator to tell me what this integral is. So let's do that. So here's what my calculator says that answer is for that integral, right? And it helps me out because that would be a little bit, I mean, we could do it by hand, but if we have a calculator to help us, let's use that calculator and let it help us. So I like having the calculator there to help me. So that answer is 24. 24 is that whole entire thing right there. Okay, minus a minus is of course a plus. So when I want to solve this for f sub 3, I subtract 1 from both sides, and I get 23, right? Which is exactly what I got when I did it the other way a minute ago. Okay? So it might be a tough thing. Maybe this equation is crazy hard to antiderive, right? So we're going to have to use, well, we're going to want to use this fundamental theorem of calculus in order to solve for different function values, right? Different function values. This is going to help us find maxes and mins also later, but for right now, we're just practicing the math. Okay, so here we have our f prime is sine of x squared, and we know that f of 1 is -5. Find f of 2. Okay, so this exact question wording is a very giveaway that we're going to be using the fundamental theorem of calculus. Okay, what is your lower bound going to be?
1.
Right, 1 is going to be the a value, and 2 is going to be your b value. Okay, so when we set this up, we're taking the integral from 1 to 2 of our function, which is sine of x squared dx. Okay, so if you had a FRQ problem on your exam and you wanted to solve this, you would write this down first, right? F of 2 minus f of 1. Right? That is stating that you know the calculus involved. So that's all that you would have to write. So now we're going to use our calculator to help us figure out what that number is. We know that f of 1 is -5. Right? F of 1 is -5. So now let's figure out what our sine of x squared dx from 1 to 2 is. Okay, so 0.494508 is that integral. Minus a minus is a plus, so when I want to solve this for f2, I'm going to subtract 5 from both sides. Okay, so I get f sub 2 being -4.505. So -4.505, and then my other decimals are 4 and 9. But you can truncate to the third decimal. You don't have to worry about rounding or anything. That is a perfectly good answer for AP Calculus. Okay, our last question says, what if you were given f2 and asked to find f1? So if we had the integral from 1 to 2 equals f of 2 minus f of 1, that means we're going to add f of 1 to this side, and we're going to subtract the integral from the other side. Okay, so you don't always solve for the top one. You could also solve for the bottom just by doing some algebraic manipulation, right? There's nothing too crazy about that. So we're going to practice some more of that kind of stuff here shortly. So here we have a graph of f prime, right? This is our derivative, and we're asked for things about f, right? So this is your classic case where we're going to be taking the antiderivative using our fundamental theorem, right? The fundamental theorem from a to b of your derivative function is f of b minus f of a. So let's see. So if I have 0, right, which one is lower, -2 or 0? Right, -2 is. So I'm going to be finding the integral from -2 to 0 of my derivative function, and that's going to be f of 0 minus f of -2. Okay, so we always start off with the calculus. -2 is a lower bound, 0 is my upper bound. Okay, so let's think. Remember what it is we're finding when we're taking an integral. We're finding the area under the curve. So from -2 to 0, what is the shape of the area underneath my curve? Right, that's a triangle. So I'm going to find this value by doing 1/2 of the base, which is 2 units, times the height, which is 4 units. Okay? An integral is the area underneath your curve. Equals f of 0 minus f of 2, which was 5. So f of 2 is 5. So we replace things with what we know. And let's see, half of 2, well, that's 1. 1 times 4 is 4. 4 plus 5 is going to be 9. So f of 0 equals 9. Let's do those same kind of things here for part B and for part C. We're going to find f of 2 and we're going to find f of 6 using our fundamental theorem of calculus. So those are our last two answers. So the area from -2 to 2, right, is this triangle with a base of 4 and a height of 4. So that area is 8. So the y value when x is 2 is going to be 13. And then from -2 to +6, we have our triangle, and then we have a semicircle. We have to remember that anything below the x-axis is negative. So 1/2 of pi 2 squared is going to be a minus 2 pi as our area. So 8 minus 2 pi is the integral, the area from -2 to 6. And when we add 5, we add 5 to the 8 to get a total answer of 13 minus 2 pi. Okay, so the integral is the area under the curve if we're not given an equation. Okay, so let's do the same thing here with this next example where we're given some areas. So this area here is going to be 4. This area down here, it says, is 9. And this area here is 2. So there are our numbers. F of 0 is 1. F of 7 is -4. And F of 9 is -2. So now it says sketch a graph of f. So let's go. F is 0. When as 0, we were at 1. Okay, I know f of 3 was 5. 2, 3, 4, 5. So we're 3 and 5. There's the point there. 7, I'm at -4. 1, 2, 3, 4. And at 9, I'm at -2. So let's make it nice and continuous. All right, I don't know that that's a local max or a min, but for the most part, that looks pretty okay. Okay, so fundamental theorem, right? Pretty nice stuff. So here's an application. Pizza with 95 degrees Celsius is put into a 25 degrees Celsius room at some initial time. Okay, the pizza's temperature is decreasing at a rate of, so now we have a rate. Rate means derivative. So rate is the derivative of temperature as this equation. Estimate the pizza's temperature when t equals 5. Okay, so this is one of our fundamental theorem problems. we have a lower bound of 0 and an upper bound of 5. So our temperature is going to be the integral from 0 to 5 of your rate, right? The rate of temperature is 6e to the negative 0.1 t. And then, of course, dt, right? So dt is going to be your variable of integration because t is the variable in your problem. And that equals the temperature at time 5 minus the temperature at time 0. Okay, so that's how we're going to use this fundamental theorem now to figure out what the temperature is after 5 minutes. So let's turn our calculators on again so that it can help us take this derivative or antiderivative, because Lord knows I don't want to do that by hand. So we have a negative 23 degree decrease of temperature. So when I add my 95 to my 23, what do I get? I have a temperature of 71.3918 degrees Celsius. Right? This is not Fahrenheit degrees. This is Celsius degrees after 5 minutes. Okay? Very good job. That's how we're going to use our fundamental theorem of calculus.